Okay, so welcome to revising some physics. We are going to start with momentum and get rolling on that. Please make sure to subscribe and hit the like button if you like the video and offer some commentary in the comments if I made a mistake or if you just want to give your opinion, you can do so at any point. Okay, so we're going to look at the definitions first. So these are definitions from the exam guidelines. I suggest you study the definitions according to your exam guidelines to avoid losing unnecessary marks, okay? Those definitions are definitely where you can score an extra 2 marks here, an extra, maybe even 6 marks, okay? So firstly, momentum is defined as the product of an object's mass and its velocity. Newton's second law of motion in terms of momentum is defined as the resultant or net force acting on an object equal to the rate of change of momentum of the object in the direction of the resultant or net force. Impulse, the product of the resultant or net force acting on an object and the time to the resultant or net force acts on the object. A closed or isolated system is defined as a system on which the resultant or net external force is zero. The principle of conservation of linear momentum is defined as the total linear momentum of a closed system remains constant, meaning it's conserved. Now, that may have just been a whole bunch of words and not a lot of understanding, and that's totally fine. We're going to go through all of these topics as we go through the actual content. Right, so if we look at momentum, and what we define momentum as, and just look at the general concept of momentum. Momentum is the motion of an object can be changed by changing its mass or velocity at which it moves. Momentum is therefore the description of an object's amount of motion. Momentum is limited to linear motion and therefore called linear momentum. What do you mean by linear? Linear meaning it cannot be diagonal. We cannot have diagonal momentum. Okay. So when I think of mass and velocity or just momentum in general, I always think about an object having movement. Okay, and that's literally what momentum is an object having movement. Okay, and if you want to look at the following formula, which is important that you know, your momentum is represented by a small letter P. Your mass is represented by a small letter m, and your velocity is represented by a small letter v. Remember, your velocity is measured in meters per second. Your mass will be measured in kilograms. So therefore, your momentum will be kilograms per meter per second. Okay, so this is the SI units. Very important that you look at the SI units and you make sure you know how to use them or how to convert 2 kilograms, for example, because in your exam, they can ask you, in the question, they can give you grams. Okay, do not use grams, use kilograms. Okay, for the most part, almost every formula you have on your information sheet is kilograms if you're in doubt of whether or not to use a specific grams or kilograms. Usually, you need to make sure to check it yourself. So I think the best way to learn physics is to literally do it, okay? So I'm going to look at a worked example first. Okay, and this worked example is from the Siyavula textbook, so you can go take a look at that if you would like. So what is, literally just as I said about the grams, right? There we go. So it says, a soccer ball of mass 420 grams is kicked at 20 meters per second towards the goalpost. Okay, so here's your frame of reference. The question asks, calculate the momentum of the ball. So we have our mass, but we need it in kilograms, okay? And we have our velocity over here. And we also have our frame of reference. So now we can calculate our momentum. So, of course, we need to identify what information was given. We have the mass of the ball, we have the velocity, okay? However, we know that we need to convert the mass of the ball to the correct SI units. So if we look at in this worked example, they converted the 420, okay? They divided by 100 to get to 0.42. Not 100, by 1,000. I apologize. I just wanted to make reference that whenever you have like a kilo usually means it is 1,000 of something, Okay, so if you are confused of whether you want to convert to something kilo, anything, try dividing by 1,000. Okay, usually it is what you're supposed to do. Okay, now the formatting in this slide is a bit off, but we are going to use P is equal to M multiplied by V, which is the one we saw. We're then going to substitute 0.42 and 20. So if I have P is equal to M times V, then my mass we found was 0.42. Velocity was 20, and then we're going to get it at 8.40 kilograms per meter per second. Does it make sense? Excellent. Now remember, we had a frame of reference. Because momentum has velocity, we know that velocity is it's a vector quantity, it's a vector value. So therefore, momentum is also going to be a vector, meaning it has direction. So therefore, we're going to use our frame of reference, which was the goalpost. Okay, we can see that it's a positive momentum, meaning it's traveling in the direction of motion. So in the same direction as my velocity. So therefore, in the direction of the goalpost will be my frame of reference. Okay. I'm just trying to see here. Okay. Here's another example. This is from the Physics Platinum textbook. I will provide all of the links at the bottom so that there's no, copyright issues. This is not my work. I don't claim it is my work. This is from the Platinum Physical Science. I think it's book 1, or it's the physics book rather. Okay, so in the question, it asks, or it says, a car has a mass of 800 kilograms and moves at a velocity of 40 meters per second west. What is the momentum of the car? Once again, we start with our formula. It's very important that you use the formula as stated in your information sheet. So whenever you write a formula, make sure you write it exactly as you saw it in the information sheet. Okay, then we substitute the 800 kilograms and we substitute the 40. They gave us west as a direction, so there's our reference. We see that the momentum is traveling in the direction of motion, so in the direction of my velocity, so therefore it is also traveling west. So momentum is also west. So over here, question 2 is from the Platinum textbook. It's the same thing as the Siyavula question, so we don't have to go through that. Now, change in momentum is literally as it says, when the momentum of an object changes. Now, how can the momentum of an object change? Firstly, the momentum of the object can change if there's a change in mass or velocity. Now, if you think about it logically, can my object just randomly lose weight? Okay, no, okay. Usually in your questions, your object cannot just randomly lose weight. Yes, you could think, okay, if you're throwing a rock against a wall, maybe a piece of the rock is going to break. Okay. But we're just thinking in terms of just in an isolated system. Let's think what could happen. Okay. So mass is out of the question. Don't think about your mass changing. Think about the velocity changing, because I mean, our objects can easily speed up or slow down, right? So for example, if you look at this example, actually with the tennis ball is traveling it's traveling faster towards the wall. It hits the wall. Now we need to think Newton's third law, right? But then at the same time, we also have to think about energy transfer. If you think about when, even if I hit the desk, that sound is energy transfer. So when the tennis ball hits the wall, you hear a sound or there's heat generated and it bounces back. But when it bounces back, it's going to bounce back with a slower velocity, because some of the energy from that tennis ball is absorbed in the wall. Okay, and then we can have a change in momentum. So if you read this question, a tennis ball with a mass of 0.12 kilograms is hit and moves towards a wall at a velocity of 5 meters per second. This velocity is referred to as the initial velocity of the ball, just before contact with the wall, and its direction is positive. When the ball hits the wall, that's the collision. The velocity of the ball changes to 3 meters per second in the opposite direction. This velocity is referred to as the final velocity of the ball, just after contact with the wall, and its direction is chosen as negative. Look how they chose the different directions, right? They chose the direction towards the wall as positive and the direction away from the wall as negative. Very important when you're trying to use a frame of reference in our final answer. Okay. So if we then go to how they calculated it, so they In the textbook, they took a very step-by-step approach, okay? So firstly, they calculated what was the initial momentum. So the momentum of the ball traveling towards the wall. The mass was 0.12 kilograms, and we had a positive 5 initial velocity. So then we get the momentum as 0.6 kilograms per meters per second towards the wall. Then we calculate the momentum after the collision. So this is with the final velocity. So 0.12 multiplied by -3. Remember, we said that the motion away from the wall is negative. So therefore, we get a negative momentum because momentum is in the direction of my velocity. So in the direction of the motion. And the direction of the motion is in a negative space, okay, away from the wall. So the momentum has 101% changed. You can see even in the numbers. That leads us to our next important kind of formula. Once again, this is from the Platinum textbook, physics textbook. This is not my working. Okay, so we can, whenever you have a change in anything, guys, for anything in physics, if you have a change in something, you always say, what was the final value minus the initial value? And that is change. So this happens as well with your momentum. My final momentum subtracted from my initial momentum will give me the change in momentum. Okay, however, we can also kind of use a little bit of maths here, and we can see that our mass is not going to change. Okay, I've not seen a question, and I don't think it's even in your exam guidelines where they say, ask questions about the mass changing. It's just that no. So your mass is always going to remain the same, okay? It's your velocities that are changing. So therefore, your mass can just be taken out as a common factor, and you can focus on the change in velocity, which leaves us with this following equation. So if we use the example from before with the tennis ball, we can substitute the mass of 0.12, the -3, which was the final velocity. Now, the reason why it's negative here, it's because we said minus and then it's +5, which is literally just -5. And then we get a negative momentum in total. So therefore, the change in momentum, okay, that looks like I'm scratching it out. The change in momentum is 0.96 kilograms per meters per second away from the wall. Why? Because our final answer was negative, which tells me it was in the direction away from the wall. Right. Now there is a document on Stanmore Physics. I'm trying to get to the document. And it's a really useful document to look through the different scenarios that you could get for momentum. Okay, it's under the study notes section. I believe, I'm trying to think now, what's it even called? I believe it is under some sort of heading or title to do with momentum and impulse, but I'm not too sure. I'll have to find this document again. But it's a very useful document to just look at the different cases or scenarios that the examiner could ask you. Okay, so the first one is a very simple momentum question. We have a ball that is moving at a velocity towards a wall. Okay, this one is just simple, easy. We just take whatever is the mass of that ball and we take whatever the velocity is, and that's it. Okay, so this is a very simple momentum type question, which you probably won't get in an exam. Then we can, of course, have a change in momentum question, which we've just looked at. We could have that momentum of where it bounces off the wall, and you'd have to then have the final velocity, or maybe you have to calculate the final velocity. You can also use your change in momentum in a vector diagram. Okay, now the next case is if the object stops. So for example, a tennis ball hitting the net stops the ball but doesn't cause it to bounce. Okay, so what we have here is that the tennis ball is traveling at an initial velocity, right? Or has an initial momentum, but then it stops. If an object stops, that means my velocity is equal to 0. And if my velocity is equal to 0, then my momentum is also equal to 0. Remember, momentum is an object in motion. If there's no motion, there's no momentum. Okay, very important. Then case 3 is if an object continues more slowly. Okay, this is where we were looking with the tennis ball, right? So if we have the tennis ball, so in this case, maybe it went through the net, for example, okay, and it continued, but it of course lost some of its momentum. Remember, energy conversion stuff. Okay, so it's traveling at initial velocity, but notice how the final velocity is going in the same direction. This is where it's very important to make sure you specify, like for example, towards the net, or to the right is positive and to the left is negative. You can just say positive and then do that, or say negative and do that, or write it out. Positive is right, etc., etc. Right is positive, etc., etc. Just let the marker know what direction you chose, and also for yourself. Now, if the object gets a boost, so I don't know, it goes through like a particle accelerator or something, something happens, okay, and the object increases in speed. So once again, we have an initial velocity, then we have a final velocity that will be faster than the initial velocity. So there's still a change in momentum. Okay, in the next lesson, we're going to take a look at Newton's second law in terms of momentum. I hope you found this video interesting and helpful. Thank you.